Hello. Today we're going to look at interpreting or trying to reason out questions involving linear and quadratic functions, or the graphs of linear and quadratic functions. And we're going to do these questions out algebraically, and we're also going to do them out using our graphs, and we'll see that we get the same answers. And it's important as much as we can to make this link between the graphs, the pictures that we're drawing, and the functions, the algebra, because they really are the same thing. And if we can get comfortable with that, then lots of things start to make more sense. So let's jump into some examples. If I have f of x is equal to 2x plus 1, that's the red line that I have already drawn in here. We know how to get these graphs at this stage. And the blue curve, our smiley face, is our positive quadratic here. So g of x is a positive quadratic. There's a plus 1 in front of our x squared, so it's a smiley face curve. Now, if I'm dealing with f of x, my red line, straight line, and I have x is equal to 3, what would y be equal to? Well, I put in f of 3 would be equal to 2 by, I put it in brackets 3 plus 1. I put that into my calculator and I would get 7. So I would get the point, coordinates of my point would be 3, 7. Let's try this on the graph. The way that we read our graphs is that we are going to usually start with whatever letter they have given us, and we're going to find the other letter. So the way that we're going to do this is we are going to go up from x is 3 up to our function and go across. So we're going to go x is 3 up and across, and we get to y is 7. So the coordinate was x is 3, y is 7. So in the door 3, up the stairs 7 gets us to our point on our red line, f of x. Now, we can see there that the algebra and the graph give exactly the same result. Now let's take another example, f of minus 1. Well, that means that x is going to be minus 1, so we put in a minus 1 in brackets anywhere we had an x. And when we put that into our calculator, we are going to get that that would be minus 1. So our coordinate then would be minus 1, minus 1. X would be minus 1 and y would be minus 1. Let's see what we get when we check that on our graph. So we want to go from x is minus 1. So x is minus 1. This time we have to go down towards our red line. So we go down and across, and we get to y is minus 1. So the point in the door, minus 1, down the stairs, minus 1, is on our red line. That's a point on our red line. So that is checking out. We have our algebra and our graph giving the same answer. Next, let's have a look at the y-intercept when x is 0. So the y-intercept means when we're crossing the y-axis. So when are we crossing the y-axis? Well, let's put in x is 0 into our function. And we get 1. So the point 0, 1 would be our y-intercept. Let's check if that works out. We start at the origin and we are going to go up to our line, and we go up to y is 1. So we go in the door, not at all, because we're staying at x is 0, and then up the stairs 1 gets us to our y-intercept. A slightly different question. Now we're told a value for y and we want to find a value for x. So here we have y is equal to f of x is equal to 5. Remember that y and f of x are two ways of saying exactly the same thing. So f of x is equal to 5. Well, f of x is equal to 2x plus 1. And this is apparently now equal to 5. Well, this is an equation I know how to solve. Minus 1 from both sides. 2x is equal to 4. divide both sides by 2, and I get x is equal to 2. So my point should be 2, 5. So let's check out whether that works or not. I want to know when y is equal to 5. So this time I was given a y value, so I'm going to start at y is 5. And I'm going to go across to my red line and then go down to see what my x value should be, and it's 2. So I go in the door 2, up the stairs 5, and that point is on my line. So all of that is working out. Now, another value for y. We want f of x is equal to 0, and I know that that is a special situation which I call a root. So I'm looking for where my function is crossing the x-axis, where y is equal to 0. So where y is equal to 0. So let's have a look at when that happens algebraically. So I have f of x is equal to 0. So I have 2x plus 1 is equal to 0. Subtract 1 from both sides. I get 2x is equal to minus 1. Divide both sides by 2. And I get x is equal to minus a half. So my coordinates would be minus a half and y is 0. Let's see what happens with our red line. So we're looking for where our red line is crossing the x-axis, our horizontal, our side-to-side axis. So we start at the origin, we go in the door, and yep, it looks like we're going about minus a half. That's about halfway between 0 and minus 1. So that point there would be at about minus a half 0. So that checks out. Our algebra and our graph are giving us the same answers as we would hope that they would, because they should really mean the same thing. Now let's try and do the same type of work with our quadratic. So we have g of x is equal to x squared minus 6x plus 8, and I want to know what g of 1 is. So that means what is the value for y when x is equal to 1. So I sub that in. Anywhere I have an x in my original equation, I am going to put in a 1. And when I do that, I am going to get 3 for my answer. So that means the point 1, 3 should be on my graph. So let's see what happens. I am looking for when x is 1. So I start at x is 1, and I go up to my blue line this time. Now I'm dealing with g of x, it's the blue line, and across, and I get to my y value is 3. So my curve is giving me the same answer as my algebra did. And it's important that we're putting in these dashed lines. If we're doing a graph equation in the exam, we must put in our dashed lines. If they ask us to use our graph, we're going to put in our dashed lines like I am here. I'm getting rid of them each time so that our graph doesn't get too messy, but in the exam you'd leave them there and we'd have our dashed lines on our graph to show that we used our graph to get our answer. Now, let's find the roots of g of x. So we're looking for where g of x is equal to 0. So even if we're not sure what to do there, we're going to write that down. X squared minus 6x plus 8 is equal to 0. Now this is solving a quadratic, which we do by factorizing or using the minus b formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a, that formula. And in either case, whichever method we use for solving it, well, we'll say we do factorizing in this case. If you factorize that, you will find that your factors are x minus 2 and x minus 4. So we get x minus 4 would be equal to 0, or x minus 2 would be equal to 0, and x would be equal to 4, or x would be equal to 2. So our points would be 4, 0, and 2, 0. And factorizing is something that we can continue to practice in terms of our algebra, but our main focus today is on our picture. So let's see if our algebra answer is the same as our picture answer. So what are we looking for in the roots? We're looking for where our blue curve, our smiley face, because it's a positive quadratic, crosses the x-axis. Well, that happens at x is 2 and x is 4. So x is 2 and x is 4. So we get the same answer here. So our algebra and our graph are giving us the same answer, which is good. Now if we're asked g of x is equal to 3, what would that give us? So then we have x squared minus 6x plus 8 is this time equal to 3. And I'm solving a quadratic again. And I take 3 from both sides because I want to have this by itself. I want to have everything over on the left-hand side when I'm solving a quadratic. Sorry, that should be plus 5. When I factorize that, I will get x minus 5 on x minus 1 is equal to 0. So x minus 5 is equal to 0, or x minus 1 is equal to 0. So I'd have x is equal to 5, or x is equal to 1. So I'd have my point 5, 0, or 1, 0. And does that work out? Well, what am I checking this time? I'm looking for where g of x is equal to 3. So where is y equal to 3 for my blue curve? Well, y is equal to 3 means I start at y is 3 and I'm going to go across to my curve. But I can actually see there's another point here where my blue curve is at y is equal to 3. So this is the line y is equal to 3. And I'm looking for where my blue curve is at that height. And that happens at x is 1 and x is 5, which is what I got from my algebra. So, excellent. We're still getting our same answers. And remember, we put in our dashed lines on our graphs in our exam. Next, we want g of 0. So that when x is 0, and we know that that's called the y-intercept, so we're going to put in x is 0. So we'd have 0 squared minus 6 on 0 plus 8. We'd have y is equal to, would just give us 8. So we'd have 0, 8 would be our y-intercept. And does that check out? Will we go to the origin and then go up, and we hit the blue line crosses the y-axis at y is equal to 8. So that does indeed work out. Next question. Where is f of x equal to g of x? This is another way of saying where they intersect. So where do our lines intersect? Whether they cross each other is another way of saying where they're equal to each other. And we just look and we see that the red line crosses the blue line when, to read our point, we start at the origin, in the door 1, up the stairs 3. They cross over each other at the point x is 1, y is 3. And finally, we want to talk about where is the minimum of g of x. Where is the minimum point of g of x? Well, minimum just means smallest. So where is the minimum value of g of x? Well, g of x looks like this. Where's the lowest point on g of x? It's going to be all the way down at the bottom of our valley, at the bottom of our smile, which is going to be at x is 3. So we go in the door 3, down the stairs minus 1. So our minimum, our lowest point would be at 3 minus 1. That's the lowest point, the minimum point on our smiley face, on our positive quadratic. And those are all of the different things that we need for being able to read quadratic and linear functions.